Hello everyone, this is a quick video where I'm gonna try to explain the very basics of lighting in Unity. Or I would say lighting using the high definition render pipeline. I'm not gonna talk about universal render pipeline or the default render pipeline. This is just lighting when it comes to high definition render pipeline. So I'm going to create a project here. And by the way, I don't have anything prepared for this. This is going to be, I'm just going to be making things as we go. Nothing is really pre-planned. So let's see how it goes. I'm going to be using one of the latest versions, Unity 2023.1.19 F1. I think some of the features that I'm going to show today, they are only available in 2023. I might be wrong about that, but I believe so. So just in case, I'm going to be using 2023. Only some of the features. Most of them are available in previous versions as well. Okay, so from here, I'm basically going to select any of these templates. I'm going to use the 3D sample scene high definition render pipeline, or actually, I'm going to use the 3D core high definition render pipeline. The difference between this one and that one is like this one comes with a sample scene, meaning that, of course, it will take more time or more space in your hard drive because it needs to download those samples. And we don't care. We're just going to make some kind of a corner box or something. So we can stick to the 3D high definition render pipeline core. I need to download this template and I'm gonna call this one high definition render pipeline lighting or something like that. And I'm gonna place that one there. I don't wanna use Unity Cloud or anything, and I'm just gonna create that project. It might take a couple of minutes. As you can see, it's firing up Unity here. So it's basically downloading all the packages for that project. So we can come back when everything is downloaded. Okay, so the project has been created. And as you can see here, the first thing that you get is this pop-up window that is called High Definition Render Pipeline Wizard. And here you can see that your project has been automatically configured for high definition render pipeline. And you can see all of these options here are ticked in green, meaning that you should be able to use the high definition render pipeline. So I'm going to close this window. We might come back to it later, but for now we can just close it. And basically this is what we get, right? We get a scene with the three main components, which are camera, light, that in this case is directional light, is a sun, and we have a sky and fog volume. So the sky and fog volume, or the volume, I would say in general, it's one of the most important tools in Unity when it comes to lighting. So let me basically, I'm just going to go here to my assets folder. I'm going to create a new folder called scenes. And I'm going to save this scene. This is the default scene that is called outdoor scene. That's all good. But I'm just going to save it as something else. Maybe I'm going to call it something like O1 line maps, because that's the first thing that we're going to explain here. So let me quickly open Notepad here. So when using the high definition render pipeline in Unity, we can use different lighting methods. The first one that we're gonna be taking a look at is called light maps. And this one basically uses light maps, which are textures with lighting information to display the lighting of the scene. This is one of the most common lighting methods found in games and low-end devices. Then we're going to take a look at adaptive probes. And by the way, this is light maps plus reflection probes, which, one captures the irradiance and the other one will capture the reflections. Then we had adaptive probes, and this is an improved way of capturing the irradiance of a scene by placing many probes in the scene. We're going to take a look at that later. And there are actually two different ways of using adaptive probes. We're going to take a look at both of them. Then we also have, of course, ray tracing, which is real-time components of the light. Doesn't mean that everything is real-time. We're still going to be using rasterization, but some of the components of the lighting can be ray traced, like global illumination and reflections and refractions and shadows and many other things. And finally, we can take a look also at full path tracing, which is kind of what you usually do when working in visual effects and you work with full-time path tracers like Arnold or RenderMan or any of those. So there is no cheating, there is no baking information, everything is path trace in real time. All right, but let's start with light maps and reflection probes. And by the way, if you are working on cinematic content, most likely you would be using ray tracing. You might be using also path tracing as reference, because path tracing cannot be used like for interactive purposes, because of course it takes some time to render the frame, but it's pretty fast. But anyway, you can use it for referencing. But yeah, ray tracing is probably what you're gonna be using the most, unless you are developing games or you are creating interactive experiences for virtual reality and whatnot. And in those situations, you might ended up using these two. I'm not very interested in these two because I don't make games, but or interactive experiences. But yeah, ray tracing is probably the one that is most useful if you are transitioning from visual effects. Okay, so I'm gonna create a very simple scene, something like a Cornell box or similar to that. Not exactly, but I'm gonna create an empty object here that I'm gonna call environment. Reset the properties here, and now let me just create some kind of box here. So I'm going to create a cube. Okay, and this cube I might do something like yeah, maybe 10 and 10, and maybe here something like 0.2. Okay, for some of these methods, not for all of them, but for some of these, it is actually a good idea to create thickness in your geometry, right? So I'm not using something like, oops, sorry about that. I'm not using something like a plane, which is thin, doesn't have thickness. I'm actually using something like a cube where I can create a little bit of thickness. Shouldn't be an issue with path tracing, for example, but some of the methods like line maps, it might cause issues if you don't have thickness in your geometry. All right, so I'm gonna take that one and I'm going to duplicate it 90 degrees. I'm gonna move it down there, -5, and I'm gonna move it up here. It's also important not to have intersections in your geometry. That might also lead to issues here. So I'm gonna set that one to 5. .1. Okay, that should do. And yeah, let's get this one, duplicate it again, rotate it 90 degrees, and I'm gonna move it like over there. Okay, cool. Let me duplicate that one, put it over there. All right, and we have some kind of box, which we can use to test all these things, right? I'm not going to create any elaborated scene because I just want to move super fast. I'm going to duplicate that one, move it up there, and maybe make it something like that. And move it back. Okay, so we have some kind of encapsulated environment now. What else do I want to use here? Let me just create a sphere, 3D object sphere. All right, something like that, maybe a little bit bigger. Okay, I'm gonna get this light, by the way, and I'm going to do something like that because I want to have like some parts. Yeah, maybe something like that. I want to get some parts with direct lighting, some parts with indirect lighting and shadows and whatnot. Let me get this sphere. It's probably too big for what I wanted, so I'm gonna make it slightly smaller, something like that. All right, I'm gonna make sure it's sitting here. Cool. Duplicate that one over here, and maybe I'm gonna get these two now and duplicate both of them and maybe place them somewhere there. Okay, I have my scene. This is pretty much what I wanted. Okay, great. What else do I want to do here? Let me go here to my assets, create a new folder that I'm gonna call materials, and I just want to create a bunch of materials now. So I'm gonna start with a gray material that I can put it to something like 50%. All right, and I'm gonna assign it here and there. And okay, I'm gonna duplicate that one. Let me call it white, and I'm gonna assign it to the floor and maybe give it a little bit more luminance here, something like 75. Great. And let's create something like a red material that I can assign maybe to this wall here. So we can see a little bit of light contribution or bounce lighting contribution, I would say. This one can be called green. Right, something of that nature. And finally, I'm going to create a blue material as well. If I can spell here, blue, there you go. And make it blue. All right. Maybe I can make this to be perfect primary colors. So let's do that. And let's do the same with red, which already is purely red. And this white material, I want to assign it here as well, or actually maybe we can add a different color. Nah, that's fine. Okay, cool. So yeah, let's start looking into light maps. So we said before that there are three components of the light here, like, or that will affect the lighting: camera, sun, and sky and fog volume. So the sky and fog volume, or volumes in general, are extremely important when it comes to create aesthetics in Unity. And as you can see, by default here, what we get is this visual environment thing, which is set to physical base sky, but you could also use like a gradient or like a flat color or an HDRI. We can talk about HDRI lighting in another video. we're going to stick to physical base sky, which basically is using this sky model that is linked to the sun. And we have some fog and exposure settings here they are not that important at this stage. So the physical sky is linked to this sun, meaning that if I change the rotation of the sun, this is going to look like a different time of the day, right? So this looks like an afternoon. And if we point the light completely straight down, it will look like a noon or midday, right? Okay, but we're going to keep it just like that because I want to get like pools of lighting and shadows and penumbra and whatnot. Cool. You can create many volumes, right? So if you go here, you can create a volume. You can create another sky and fog volume, or you can create a global volume, or you can create encapsulated volumes, like a box volume, for example, right? So you get this box volume here, and as you can see, it's set to local, while this other volume that we have here, it's set to global. The difference between those is like when it's set to local, it only affects the environment once you get inside of this volume. And I guess this is very useful for games. But for example, if you add any component to that, like for example, this one here, yep. So if we add something like let me go to, for example, what can we use here? Let's use we need to, of course, add a profile first, and that will store the settings of that volume. So we can just click on new here, and now we have this box volume profile. I have two for whatever reason, so I'm gonna get rid of that one. Go back to my box volume. Now it's missing that, so I can just drag and drop over there. So now I can add overrides to that volume. So if I add something like whatever, like a color adjustment, and I make, let's say, the exposure to be something like 3 or something, or let's say 1, and the saturation to be -100. Once we get into this volume now, as you can see, we are changing the exposure and we are changing the saturation, and maybe we can do something with the contrast as well. There you go. Right? But because this is a local volume, as soon as I get outside of that box, those settings doesn't affect the environment anymore. Okay? So that's basically the basic concept of volumes in Unity. You have defined space that change the behavior of the look of your scene, or you have global volumes that then you don't need to care about the bounding box of those objects. It will affect everything at the same time. And that's what we have with the sky and fog volume. Let's get rid of that one because we don't need it. Cool. And as you can see, once we have this one as local, even if we have that one as global, it will override it once we get inside. So that's cool for creating lighting effects, especially in interactive applications. Okay, gone. Cool. So yeah, let's look into line maps. So again, line maps are textures that store lighting information. So we need to bake those textures. The downside is like baking textures can take a long time, but once they are baked, everything moves very fast, right? And your application or your game or your cinematic or whatever will perform really well. So yeah, they are very cheap at runtime, even though it takes time to generate them. Okay, so how do we do that? Because as you can see here, the lighting is not really working, right? I mean, we're seeing light leaking here, the shadows don't look great and whatnot. So we have this lighting tab here. If you don't have it, just go to Window, Rendering Lighting, okay? And the first thing that we have is this lighting settings. We don't have anything, so I'm gonna click on New. And now we have these new lighting settings. This box volume profile, we can get rid of it. We're not using it anymore. And these new lighting settings, we can call it whatever. I'm just gonna call it same as my scene. O1 light maps. Okay, great. So this, if we select that one, we have a bunch of options here. If we go to mix lighting, it says bake global illumination. Yes, that's what we want. Lighting mode, I'm gonna set that one to bake indirect. And light mapper, this is the tool responsible for baking light maps. You can use the CPU or you can use the GPU. And then there are some other settings here that you can change, and that will dictate the quality of your baking. Okay, things like light map resolution, which is 40 texels per unit by default. To make things quicker here, I'm gonna set that one to 20 texels per unit, so it's a little bit faster. The max light map size, so this would be the resolution of your light map. So the higher the resolution, the better, of course, but the more time it will take to compute. And these are settings that you can experiment with. Okay, cool. But yeah, if we go back to lighting, then we're using those settings here. You can have multiple, right? Because you can have something that is super high quality and something that is low quality. So you can bake different resolutions while you're working. So that's pretty cool. It's almost like a procedural way of working. Like you have your settings for the final product and you have your settings for work in progress iterations, for example. Right. Then if we go to our light is set to mode real time, but it can be set to baked or mixed. If you don't need the light to be real time, meaning that, you know, it changes the behavior in real time once you modify the lighting, you don't need to set it to real time. You can set it to baked or you can set it to mix if you have objects that are moving in the scene. I'm going to leave it as real time for now. For the geometries, and by the way, now that we're here in the lighting, yeah, that's one thing that I show you. Another thing is the shadows, right? So if you disable shadows, obviously you wouldn't have any shadows. If you enable shadows, then you have here like the resolution of those shadows by default is 512, but you can go to something like medium, so it's 1020, or you can go to something like ultra, and then you would have better quality, right? So depending on what you can afford, you can change this one. I'm gonna set it to medium. And then you also have contact shadows if you want to, so you can get like some contact shadows that right now it looks a bit funky because it's not baked, but you can get contact shadows if you wanted to. Okay, great. So for geometries to participate in global illumination, I'm going to select all of them. They need to be marked as static. And once they are marked as static, you can have this thing here that says contribute to global illumination. Okay. If I deselect static, you can see that this doesn't work anymore. I mean, if I enable global illumination, it gets marked as static. But also, you can say here, for example, like, oh, I want this to contribute to whatever component of the lighting specifically. But yeah, I'm gonna mark everything as static. Again, select all of them, contribute to global illumination, receive global illumination. You can set that one to light map or light probes. For now, we want to stick to light maps. We're going to take a look at light probes later. Okay, so now everything should be fine. You see that here, when you select the objects, we have something like scale in light map. So basically, this is the scale of 1, meaning that it's going to use this scale that we have here. But you can multiply that to have a higher resolution for a very specific object in the scene if you wanted to. Okay. If we go now to lighting, we can click on generate lighting. Okay. Again, all of this has been dictated by your lighting settings. So we are baking indirect, we are using the GPU, and then these are the settings that we're using. So we can create, we can click now on generate lighting, and this will create textures, again, with the lighting information baked into it. So this light mapper tool, it will create those maps, it will compress them, and it will store them on disk as EXR. Okay, so I'm going to click on generate lighting, and this might take a few seconds. And as you can see here, this is using my NVIDIA GeForce RTX 3080 that I have here in my laptop. And once this is done, we can take a look at the result. Okay, so the lighting is baked, and as you can see now, this is looking quite nice, right? We get those occluded spheres here, the light spheres here, and everything seems to be looking fine. We get also like color bleeding from this blue wall here, from that one there. And the reason being is that, again, if we go to the lighting settings, you know, we're using this bake global illumination and this real-time lighting as well. So we're getting all those cool stuff. We still have some issues here with the leaking of the light, and that is actually not leaking of the light. That is how the camera is viewing the shadows. So if we get closer, you can see that that is actually filled. So this is basically for performance reasons. But you can change that by going to the fog volume and adding these shadows, right? Let me get rid of it actually. You can just here type shadows, and here you can control that max distance. So that's basically the cooling of those shadows. So if you do something like 20 or 10, you don't get any shadows, but as soon as you get closer, you start getting shadows. So this is also very common in games. So you need to work here with whatever you think is convenient for your scene. So if you go super far away, you don't get any shadows. As soon as you start getting closer, now you see more shadows here and there. All right. Let me disable that. So that's basically what I'm getting here. Things seems to be working fine. I'm gonna get this lighting and maybe do something a bit more. All right, something like that. That looks a little bit cooler. And I'm going to, so now if I go to lighting and I clear my bake data, this is how things look like without baking any lighting. I'm gonna bake it again, doesn't take that long. Okay, and now this looks much better, right? Cool. But we still have some things that we want to change here. You can go to window, lighting. I think it is in. It's this rendering debugger that I'm looking for now. I don't remember where this one is placed. You can find it here, and window analysis rendering debugger. There you go. I'm gonna touch it here. So here you can check different components of the lighting. So you can go to lighting, and here you can do like things like materials overrides and lighting overrides and whatnot. Here you can check like different types of lightings that you have in the scene. If you go to well, here in let me make this a little bit bigger. Here where it says lighting debug mode, you can see things like, oh, I just want to look at the diffuse lighting, or I just want to look at the contribution of the specular lighting, or whatever it might be, right? Like direct specular lighting. So that's how you can check kind of like the AOVs, right? Of what the components of the light are using. All right, I'm gonna go back to that. Cool. So another thing that is still not working, but I guess we're not seeing it, it's the reflections, right? So let me do one thing here. I'm gonna go to my materials. I'm gonna create a new material. And I'm gonna call this one something like chrome material. And I'm gonna assign it to this sphere and to that sphere. I'm going to assign that gray material there and that gray material that I think is there. I don't know. Okay, so those are gray materials. And now my chrome material. Oh, sorry. Chrome material, that one. Yep, and that one. Okay, cool. So this chrome material, I'm going to make it actually look like chrome or something. So I'm going to set my metallic all the way to 1 and my smoothness all the way to 1. So we have like a mirror ball basically. But if we take a look here, this mirror ball is reflecting the environment. Cool. But, and maybe I can move this one a little bit here. Okay, so those shadows don't overlap, which is a little bit more pleasant visually. All right, something like that. Yeah, it is reflecting the environment, but it's not reflecting the other 3D geometries. Where is this sphere reflected here? Where is this blue wall reflected there? It is not, right? So that's something we need to fix. And by the way, you see that when I look at over there, you see that the exposure is automatically being compensated for the lighting. So everywhere that I look, it looks nice. But, well, that's not how a camera works in real life, right? So that's very useful, I think, for games. But I'm not sure if it's that useful for other type of projects. So that comes from your camera. So when you go to the camera, or actually not from the camera, but from the exposure of the camera that can be controlled in the volume. In the camera, you can do things like, for example, physical camera. And now you can control things like ISO, sensor, and whatnot. But the important bit is here. You have this exposure thing. If you don't have it, you can just click on exposure, and it doesn't show it to me because I already have it. But you can enable that one. Now it's fixed, but if you set that one to automatic, it will basically expose everything correctly. So I can see, even if I look at something as bright as the sun or something as dark as that corner, everything looks fine. But you can set that one to fixed and fix it to a whatever exposure value. So if I say something like 13, then it doesn't compensate for that, right? Or maybe something like, let's say 15. So it's quite dark here as expected, but when I look at there, you know, the sun is bright, so that's all good. So now it's working as expected, or as a real live camera would behave. So let's say something like, I don't know, 15. Sorry, 12. So we still see quite a lot. Okay, so yeah, now that is overexposed, and here is correct. That is the behavior of a real camera. Yeah, but we still have the issue of the reflections. So to do that, we need to create another component, which is light reflection probe. Okay, and remember that I wrote here at the very beginning that in this very first mode of lighting, we are looking into light maps, which we did already, and reflection probes. This is what we are using now. By the way, I forgot to say the light maps that we bake. If we go to lighting, if you go to baked light maps, here you have the texture, the EXR, the 1K resolution texture that we baked that contains the lighting information. So basically, if you click on Open Preview, you can see that baked map here, right? And if you select any geometry, you can actually see where it belongs in this light map. Okay, cool. But yeah, we're still missing the reflections. So let's get the reflection probe that we just created. And here we can encapsulate the scene basically. So, well, we actually have to do it here. We can just take that one and try to cover the scene. I'm just gonna do that as quick as possible, basically. Okay, so this one I can set it to baked, right? Or you can set it to real time as well. And if you set it as real time, you can see that you start seeing reflections there. But we actually want to bake the reflections. So let me go to baked reflections. And now if I bake the lighting again, this is going to bake the lighting, but now it's also going to bake the reflections. There you go. So now, as you can see, I'm getting those reflections in these materials, right? So it's not only reflecting the environment as it was doing before, but now it's also reflecting the surrounding objects. Okay, cool. If we make this material, this chrome material, let's make it a little bit rougher. Maybe something like 0.8. This might not be super accurate now, and we might need to bake the lighting again. Oh, by the way, you don't need to bake the lighting every time. You can actually just bake reflection probes, and that will bake only the reflection probes, but not the lighting, in case it takes a long time. I know we have like better reflections. So basically this reflection probe, and actually you can see that it has some kind of a probe in the middle, like a sphere, where you can check if it's doing the right thing. If you have a large scene, you would need to basically add more reflection probes where needed. Okay, so you can have multiple reflection probes, of course. It will take longer to compute, but it will do a better job. Okay, the more reflection probes you have in the scene, the more exact the reflections would be. Okay, great. So this is basically everything that I wanted to say about light maps and reflection probes, which, if you remember correctly, was the first way of lighting in Unity. So let's take a look at the other ways. But just to make things clear here, I'm going to disable these icons so we see only that. If I go to lighting now and I clear the lighting, take a look at the difference between this lighting that works fairly okay and that one. Okay, so the difference is massive. Cool. So let's carry on and let's take a look. I'm gonna save this scene now as light probes, and save it. And now we can start looking into adaptive probes system in Unity. So light probes. What is the main difference between what we already seen, light maps and reflection probes, and adaptive probes, or light probes in general? Well, basically, light probes are used for dynamic objects that cannot rely on baked lighting information. So, and that is specifically or especially noticeable when you have a light that is set to bake and no real time or mixed. Because right now, if we haven't changed anything, right? The only thing I've done compared with the previous example was to clear the baking data, right? But if I bake the lighting data now, this is basically what we've been doing so far. Again, light maps and reflection probes, right? So once this is baked, as you can see here, if I take this object and I move it, well, the lighting information is baked. So obviously this doesn't work with animated objects. So let's clear all the data. So we go back to the default lighting where things don't really work very well, in the sense that we don't have occlusion, we don't have global illumination and whatnot. I'm going to set my sun to be, instead of baked, mixed, because we still want to use light maps for everything that is not going to move, like the environment, and we want to use reflection probes, lighting probes for things that are going to move. So I'm going to do one thing here. I'm going to take this sphere and I'm going to create a quick animation. So basically, I'm going to create an empty object that I'm going to call timeline. I'm going to go to my timeline here, create a timeline that I'm going to place directly in my scenes light probes. Let's put it here. And now I'm going to take that sphere, drag and drop over here, create an animation track. And let's start recording this. So maybe this is going to be my first frame. Maybe I go to 120 or 100 frames and I move this one back there. Great. So I have this animation so far, and then I'm going to go to 200 and maybe bring it somewhere there. Okay, so that is my animation. So, okay, we're getting this, which is not perfect, but we get some kind of interactive lighting, which is not baked yet. So we're going to have to bake it. When it comes to light probes, we have two different versions. We have the legacy light probe system that I guess we don't really want to use it anymore, but I can show it to you anyway. And then we have the new adaptive probe volumes, which is not as efficient, but is much faster to work with because it doesn't really require a lot of human input. So this sphere that is actually moving cannot be static anymore, right? But we still want to contribute to global illumination. But in this case, we don't want to use light maps. We want to use light probes. So I'm going to select light probe in there. The other geometry, we can keep those to light maps. That's all good because we can combine both. We can combine light maps for static object and light probes for dynamic objects. And if we wanted to, we can actually use light probes for everything. We can do that later. Okay, so that is all. That is all set. So now we need to add the light probes. So I'm basically going to go to game object, light probe group, and we get those probes, which are those small spheres here and there. So we can make that smaller. Something important about these light probes is like don't place them inside of all the geometry. Okay, so I'm gonna make sure that this is kind of covering everything, but it's not intersecting with anything. Okay, that's good. And now we can go to edit light probe positions, and then we can add more probes where needed. So we can click on add probe, and then there is another probe. Or we can also select something we already have, a bunch of probes, duplicate them with Control D and move them, and then we have more probes here and there. Okay, so I'm gonna do that and basically fill in my environment with these light probes. And you should be placing light probes where there is a change in contrast. Like for example here, right? Here there's a change in contrast because we have those shadows. So in order to get that properly, we should get some light probes here. So I'm gonna select maybe I'm going to select, or I can just add from scratch, and I'm gonna add some of these like here. And as you can see, this is a very manual process, right? You need to add probes manually. Or duplicate them manually, and just, this is a time-consuming process. But anyway, I've done this job, which is maybe not amazing. I can select a bunch more, duplicate those, move them over here. Maybe this is just good enough. Okay. Maybe these two, duplicate them and move them over here. Maybe these two, duplicate them and move them over there. So we have a good coverage now. Okay, cool. Cool. So now, again, if we have all the objects using, all the objects that are moving using light probes, then we are good. So I'm going to go to lighting, and I'm going to generate lighting. Okay, so this is baked and is looking pretty decent. And yeah, and now if we take a look at our animation, it's getting that dynamic animation much better than before. We're not getting issues with baked light maps and yeah, this is generally speaking working well. All right. So this solution is very efficient for mobile games and any other low-end devices. At the same time that you can combine that those light maps with this light probe system that works quite well. But again, it's very time consuming. You need to do this. Imagine you have a big environment. This will take a long time. So Unity introduced a while ago something new called adaptive probes instead of light probe group. So let me go back here, clear the baked data so we don't have any lighting information stored, and I'm gonna get rid of this light probe group. Okay, cool. So first of all, you need to enable this system in your settings. So let's go to Edit, Project Settings. And here we can go to the high definition render pipeline settings. And now here, if we go to frame settings, camera, lighting, you need to make sure that you have these probe volumes enabled. Okay, this needs to be enabled. It might not be by default, so make sure that that one is enabled. In render, here, actually, sorry, not here in render, but in real-time reflection and baked or custom reflection, we also need to enable it. So if we go here to real-time reflection, lighting, we should have this probe volume enabled, okay? And same in this baked or custom reflection lighting, we should have these probe volumes enabled, which I didn't have, so I'm going to enable that. Okay, that is all good for now. What is next? So now we can add a game object. Again, if we go to lighting, now we're going to add a reflection probe, probe volume. Before we use we use the reflection probe way before. For reflections, we use the light probe group that we tweaked manually, and now we have this probe volume. Okay, great. And then we get this thing here. Let me reset that, and that one is there now. Okay, so here it says probe volumes are not enabled. Make sure light probe system is set to probe volumes in the high definition render pipeline. And I believed we did that already, but apparently no. So let me, here, where it says light probe lighting, light probe system, light probe groups, this is what we have been using so far. So let's select probe volumes, and that will enable this package, and it should be available for us. Okay, it has been enabled. So let's close that. So if we go back to the probe volume, let's see what we get here. So we can click on fit to scene, and this is gonna fit the entire scene. And mode, we can set it to local or global. Okay, so if we set it to global, of course it will affect the entire scene. So we don't really need to care too much about the bounding boxes. Okay, cool. So that is done. Make sure that the lights that you want to be used by those lighting probes, they are set as mixed or baked, and make sure that the geometry that you want to be part of the probe volume system is contributing to global illumination, and make sure that is using global illumination from light probes. And again, you can set everything that is not moving to light maps and everything that is moving to light probes. Okay, this is the same thing as we had before. So now we can just basically bake the lighting information. And again, we're combining light maps for static geometry and probe volumes for dynamic geometry. So if we go here and we generate the maps, we're gonna get the better of both worlds, basically. Okay, cool. Yeah, nice. So this is the thing, and as you can see, it's looking good. And basically, this would be our animation, and as you can see, it's transitioning well between dark and shadows, and it's doing everything as it's supposed to be done. Great. Let me clear the bake data because yeah, as I was saying, we're using light maps and probe volumes, but we can, if we wanted to, use only probe volumes because probe volumes are way faster to calculate than light maps. So if I select all the geometry and I say contribute to global illumination and I set it to light probes, this will be much faster to calculate, but it won't look as nice, basically. So let me click on generate lighting. And generally speaking, it looks pretty much the same, but in some areas, like here, it doesn't look as good. So what I would recommend, and well, the dynamic lighting should be working fine. So what I would recommend is going to your volume, and you can look for probe volume options, and here you can play with the normal bias to try to fix those issues, and with the view bias and whatnot, so you can get to something closer. But what I would suggest is, like, let me get rid of that, let me get rid of lighting. What I would suggest is, like, if all this is kind of static geometry, right? All of this is static geometry. Just go and instead of use light probes, use light maps, and this will hopefully work much better. So now you generate lighting again. It takes longer to generate because we're using light maps. I think I forgot to set that one to use the light maps. So let me generate again. Okay, and now we get the best of both worlds. Okay, so this is all working perfectly fine. Okay, cool. So yeah, that is how you combine light maps with animated objects by using the new probe volume system. And by the way, if you go to the rendering debugger, here in the probe volumes, you can display the cells. This is, wait a sec. Oh, I need to enable my icons, of course. So these are the cells that is basically dividing the scenes to basically automatically place the probes. But basically, if you go to the important one here, display probes, if you click there, you can see all those probes that have been automatically placed for you, so you don't have to do it manually as you've seen before. Okay, that's how you do it. If you want to override that, the position between them or the distribution, the distance distribution between those spheres, you can, in the probe volume, add this subdivision override and control the distances here if you wanted to. All right, cool. So that is the next scenario, which is or the previous one, which is adaptive and adaptive probes. All right, so hopefully you understood the difference between light maps and reflection probes and adaptive probes. combined with line maps. Let's take a look at ray tracing now. So I'm going to save this scene as ray tracing. Cool. And I'm going to clear all the big data, and I'm going to get rid of the prop volume, the reflection probes, and what else do I have here? I think that's it. I'm gonna start with my light. I'm gonna set my light to be a real-time light. Okay, so this one works all the time when I'm updating it. Cool. So ray tracing, it's what we call in Unity a hybrid pipeline, meaning that it still uses rasterization for rendering, but you can ray trace certain components of the lighting, like global illumination or light reflections or refraction or shadows, for example. Okay. So the first thing that we need to do is enable everything in Unity that it is required to be using ray tracing. And the easiest way of doing that is by going to Windows, Rendering, High Definition Render Pipeline Wizard. So you click here. We had a look at this window at the very beginning when we created the project, and we saw that everything for high definition render pipeline is enabled, is green. Great. But now if we want to use high definition render pipeline plus ray tracing, it's here, DirectXR. We can see that some things are not activated, but we can just click on Fix All, and Unity will fix everything automatically for us. This will take a couple of seconds, and once you're done, you need to restart the editor. So I'm going to restart the editor now. Okay, Unity has been restarted, and now you can see that everything here is green, meaning that we are good to go. Okay, so the first thing that we need to do is to enable ray tracing in the asset pipeline. So let's go to Edit, Project Settings, and I'm going to go to my high definition render pipeline. I'm going to go to Rendering, and here we should have real-time ray tracing. Okay, so this one needs to be activated. Then if I go to lighting, make sure that screen space ambient occlusion is activated and screen space global illumination is activated. If I go to reflection, make sure that screen space reflection is activated and also transparent. What else? Reflection, shadows. Make sure that screen space shadows are enabled. What else are we missing here? I think that's pretty much everything that we needed. Rendering, lighting, yes. Okay. So now that ray tracing capabilities are enabled, the first thing that we can use as a ray tracing implementation is shadows. So if you select any lighting source, here you have the shadow options. We can go now to screen space shadows and enable ray tracing. So now we get like a proper ray trace shadows, which of course improve quite a lot the look of your image. Okay, great. Then what about, remember when we selected a geometry, we can say that we want to contribute to global illumination, and then we've been choosing between light maps and light probes. Well, in our case, we don't want to use any of that because now we are not baking any lighting information. We are generating the global illumination in real time. To do that, let's select the global volume of your scene. Go to overrides, and here now you have ray tracing, and you have a bunch of things here, and you also have a lighting, and you have a bunch of things here. So the first thing that I'm going to use is screen space global illumination. I'm going to enable it, and I'm going to set the tracing to ray tracing. There you go. And now we are getting global illumination in real time with no baked lighting information. So if we take this guy and we move it, it's working as expected. Everything is good. One thing, and by the way, here you would have some options to, control the quality based on performance or quality, which of course quality is more expensive, but it will look better. Let me revert back to quality. Then you have things like clamp values, so you don't get nuns or things of that nature. And then you also have things like the amount of bounces. So if you set that one to 2, then you would get some more bouncing lighting here and there. You would also have things like sample count to get like better quality, and then you also have denoising, which is enabled by default. Otherwise you would get some kind of noise, but you can enable that one. It works very well. And yeah, you can basically play with the options there. So that is the screen space global illumination. Right. But we still having issues with reflections, right? Because now we don't have a reflection probe anymore. So let me, by the way, select this material because I don't want any roughness. I want just like a mirror. And as you can see, it's reflecting the environment, but it's not reflecting the objects. It's trying to do something, but it's not very accurate. So to fix that, we also select the global volume. We add another override, and then we can add a screen space reflection. Enable it. Enable transparency as well. Enable tracing, and set that one to ray tracing. And now, as you can see, is ray tracing reflections very well. Okay. Cool. One thing you need to be aware of, if you add some roughness to the material, I'm going to add some roughness. Where is my smoothness here? Boom. I added some roughness, like 0.7. And all of a sudden, I lost my ray trace reflections. Where are they? Well, that is because they are being clamped. So if you go to the global volume, here there is a bunch of options that you can take a look at. But the one that controls that is this minimum smoothness. By default is 0.9. If I set that one to, let's say, 0.5, then my roughness, my reflections in the roughness are actually working, because this threshold, it was 0.7 in my shader, right? So now it's actually working. Okay, I'm gonna make it maybe not as rough, something like that. Okay, great. And as you can see, this is looking much better than any other methods we've seen before, because of course here we're ray tracing global illumination and we are tracing reflections. In the same manner, we could also add screen space refraction, but I don't have any refractive shaders right now, so I don't really need to do that. And then we can also add things like ambient occlusion. We can ray trace ambient occlusion. Here we have some intensity, so if you want some ambient occlusion, you can do that as well. I'm not going to use ambient occlusion because I hate it. And then if you go to ray tracing, you can do things like light ray tracing settings, for example. And here you can control some of the aesthetics. Like here, you have the bias. You have the distant ray bias. You can play with the settings if the ray tracing is not doing what you're expecting. And you can also use a light cluster. And this is basically to cover everything. Ideally, to get all the good stuff in the ray tracing, like the reflections and the global illumination, you should encompass the entire scene within this range. So if for whatever reason this is too low, maybe we don't see it in this very simple scene. But basically, imagine that you're looking at this thing, at the reflection, and you don't see those spheres in the reflection. It might be because these it doesn't seem to be doing much here, but basically if this range doesn't cover those spheres in the background, they won't be reflected in this other sphere. So if that is the case, just get this one and make it bigger, and then it should encompass the whole scene. Okay, cool, great. So this is ray tracing. So finally, we only have path tracing. And by the way, if you're working on high-end quality content, most likely you would be using ray tracing, and you wouldn't be using the other alternatives unless you have something that is very heavy that ray tracing cannot handle. The last thing, again, is path tracing, and path tracing is basically not cheating at all. It's just physically plausible rendering, same as we do in Visual Effects. To use the path tracer, you just have to go to override in your global volume, go to ray tracing, and enable path tracing. There you go. And now you can enable it. And this is path tracing. As you can see, this progress bar, that is basically cleaning up the noise until it computes the maximum samples, which in this case is 256. But as you can see, this takes time. Even though it's quite fast, you can move around. But this is pure path tracing. So of course, it generates noise. You need to wait, and it will clean it up. So most likely you cannot use this with for real time. But you can do frames that you can use as a reference, or that you can use as a starting point for creating the look of your shot. Or if you are not doing a real-time product, if you're doing something for narrative, who cares? If it takes 2 minutes to render, it will take 2 minutes to render. Cool. But yeah, then you can do things like maximum samples. So you can set that one to 6, and it will do only 6 samples, right? So there are noise because it's only 6 samples. Let's use something like 32, for example. And now it will take a little bit longer, but it will still be noisy. As you can see here, we also have path tracing denoising that is not active. So I'm going to fix it, and it will install the denoising package. And that one is very useful. Even though I don't like to use denoising at all. Well, perhaps the new Pixar RenderMan denoising, because it's definitely the better or the best denoising that you can find out there. But anyway, now we have denoising. We can go to NVIDIA Optics Denoiser. And now we are we can use this. And as you can see, it's quite good, right? It's quite good. So basically you can use a very low sample here, A3, and then it will clean up very quickly. And of course you have a lot of splotches there because denoising is not magic. But yeah, if you increment this one a little bit, then it looks definitely much better. And if we go back to the original 256 samples that we had, once the denoiser goes over this, it should look pretty decent. There you go. So now you have something very clean. Of course, we don't see any weird artifacts caused by the denoiser here because we're using flat colors. But of course, denoiser will, generally speaking, eliminate detail from your textures and your models, unless you're using the new Pixel RenderMan denoiser, which seems to be really good. Okay, cool. So this is everything that I wanted to say about the basics of lighting in Unity. Of course, this is just kind of like a starting point of everything that you can do when it comes to lighting. But hopefully this can set you towards the right direction, because the basics is all you need to start playing with the tool. All right, so let me save this scene and I will stop it here. Maybe I will bring some more Unity content in the future. Bye bye.